Hi everyone, this is Eunice May Altamia, and I am the reporter number 16. And my topic is Kepler's laws of planetary motion. Apply Kepler's third law of planetary motion. For circular orbits, relate Kepler's third law of planetary motion to Newton's law of gravitation and centripetal acceleration. Now, let us know who is Johannes Kepler. So, Johannes Kepler was a German astronomer and mathematician active in the late 16th and early 17th centuries. He is best known for formulating the three laws of planetary motion, which describes the orbits of planets around the Sun. His work provided crucial support for the heliocentric model of the solar system and laid the groundwork for Newton's theory of gravitation. So, si Kepler ay gumawa ng tatlong laws of planetary motion, which is, first is, the path of the planets about the Sun is elliptical in shape, with the center of the Sun being located at one focus. So this describes how planets move in elliptical orbits with the Sun as a focus, or ito yung tinatawag na the law of ellipsis. Ang pangalawa naman ay tinatawag na the law of equal areas, where an imaginary line drawn from the center of the Sun to the center of the planet will sweep out equal areas in equal intervals of time. Ibig sabihin, a planet covers the same area of space in the same amount of time no matter where it is in its orbits. And the last one is the ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distances from the Sun, which means that a planet's orbital period is proportional to the size of its orbit, or its semi-major axis, and it is called the law of harmonies. Now let's focus on Kepler's third law of planetary motion, which states that the ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distances from the Sun. And we have here its formula. So t squared equals r cubed, where t is the orbital period and r is the semi-major axis.
So I have here some sample problems. Number 1. The mean distance between the Earth and the Sun is 1.5 times 10 to 11 meters. The mean distance between the Sun and Mars is 2.287 times 10 to 11 meters. What is the period of Mars around the Sun in Earth days? To calculate this problem, we will use this equation. T2 squared over T1 squared equals R2 cubed over R1 cubed. So, yung hinahanap sa problem is T2 squared. So, ayan. T2 squared over 365 squared times 2.287 times 10 to 11 cube over 1.5 times 10 to 11 cube. So, ang gagawin lang dito is i-cross multiply and then, so, ibinaba lang siya. So, yung next step is i-divide natin. So, ibababa lang natin yung 1.5 times 10 to 11 cube. So, kapag na-divide na, it will give us 472,183.1. And then, we'll need to get the square root of both sides. So, T2 is about 687 days. And the next sample problem is, it takes Venus 225 days to orbit the Sun if the Earth-Sun distance is 1.5 times 10 11 meters. What is the mean distance between Venus and the Sun? So, for this problem, gagamitin pa rin natin yung equation na ginamit natin kanina. So, 225 squared over 365 squared equals r2 cube over 1.5 times 10 11 cube. So, i-cross multiply pa rin siya. And then, kailangan nating i-divide by 365 squared both sides. And then that will give us as 1.282 times 10 to 33. Now, to get r, raise both sides to the 1/3 power. So, the r2 is the cube root of that number, which is 1.086 times 10 to 11 meters. So as you can see, it's less than the Earth's sun distance because Venus is closer to the sun. Now I am going to explain how Kepler's third law, Newton's law of gravitation, and centripetal acceleration are all related. So let's start with Kepler's third law. So this law tells us that a planet's distance from the sun and its orbital period are connected. Specifically by the law says that the square of a planet's orbital period is proportional to the cube of its average distance from the sun, which we will call r. So if a planet is farther from the sun, it takes a longer time to orbit. But while Kepler observed this relationship, he didn't know why it worked. That's why this where Newton's law of gravitation comes in. Newton explained that the gravity is the force that keeps planets in orbit around the sun. His law of gravitation says that every object with mass attracts every other object with mass. So, the sun pulls on each planet, keeping it from drifting away. So, this is the formula for gravity. Now, let's talk about centripetal acceleration. When an object, like a planet, moves in a circular path, it needs an inward force to keep it moving along that curve. Otherwise, it would fly off in a straight line. For a planet orbiting the sun, this inward or centripetal force is provided by gravity. In other words, the sun's gravitational pull acts as the force that keeps the planet in its orbit. You can actually use Newton's law of gravitation and the concept of centripetal acceleration to derive Kepler's third law. When we set the gravitational force equal to the centripetal force required to keep the planet moving in a circle, we find that the square of the orbital period is indeed proportional to the cube of the orbit's radius. So, to summarize, Kepler's third law describes a pattern which is planets that are farther from the sun takes longer to orbit. Newton's law of gravitation explains why that patterns exist by showing that gravity holds planets in orbit, and centripetal acceleration explains how gravity acts as the inward force needed for a planet's stable circular path. That's all, thank you.